Assalamualaikum warahmatullahi taala wabarakatuh. So, um, so to all seminar students, I believe just now you would have watched some presentations by the other research groups that we have in our Mechatronics department. So, Isru in particular, it stands for Intelligent Systems Research Unit. It's been around for quite some time. It's been around even since I was a student. That was sometime in 2009 or something. It has already been around. So what exactly ISRU does is that a lot of the research that is being done currently is on energy harvesting. So before actually we go into a bit deeper of the work that we do, I believe why your seminar coordinators actually wanted each research group to present about what projects or what research interest that they are currently exploring is because eventually when you do your final year project, when you do your integrated design project, um, as much as possible you would like to work with a lecturer who also has that same research interest with you, or and also when you know specifically each lecturer what are their research interests, then it helps you to sort of shop for a final year project or IDP project topic. So in just briefly, ISRO, our group members in this group is we are headed by Dr. Mabubo. Um, so Dr. Mabubo, his research area is in smart materials, and also energy harvesting. Um, In particular, if you were to find some of the publications by Dr. Mabubo, you would see there are some papers which describe about MR dampers, magnetorheological dampers. So this is a kind of smart material. How it how it is advantageous such that when you supply some kind of magnetic field to that fluid, the viscosity of that fluid is going to vary. So this MR fluid or magnetorheological fluid is widely used in prosthetics. It's used in braking systems. So that's one of the that is roughly one of the research projects that Dr. Mabubo has worked on, specifically on MR fluid. If you go to YouTube, you can find lots of illustrations, lots of videos of how when you supply a certain amount of magnetic field, how the viscosity of the fluid varies. So there is a really wide variety of applications that can be done with this type of MR fluid. So Dr. Hazrin is in this group. Dr. Hazrin's specific research interest is on energy harvesting. Energy harvesting. So Hazrin, Dr. Hazrin's recent publications that I have read was on how can we generate energy, how can we harvest energy from human motion. For example, when we walk, when we walk around, when we walk around our house, when we walk around the campus, when we walk from our class to the mahala, with that kinetic energy from that walking, how can we generate some amount of voltage, or how can we store some amount of energy so that we can use the energy to eventually charge our phone, for example. But actually, at this research stage, I don't think it's quite a challenge actually to accumulate sufficient energy to actually charge a phone, or to use in some kind of electrical appliances. But that's where the research comes into the picture. How can we continuously improve from that kinetic energy? How can eventually we gather sufficient energy to meet a certain application? So me myself, I'll explain about what I do a bit later. Dr. Salmia Ahmad, she used to be with Mechatronics. Now she's with Mechanical. Her area is on specifically on artificial intelligence, more inclined towards fuzzy logic and neural networks. Okay, and then so Dr. Salmia also the papers of Dr. Samia, which I have read, Dr. Samia has worked on developing on a two-wheeled wheelchair. Like if you have heard of Segway, Segway is for everyone. But at the same time, how can we develop a wheelchair rather than having two wheels, two big wheels at the back and some smaller wheels in front? How can you stabilize and make a wheelchair that just has two wheels? So that's the concept is similar to if you have heard about inverted pendulum. So it's a bit of it's a combination of control and also sensors and artificial a bit of machine learning as well to develop that kind of platform. So Dr. Nazril's area of specialization is on micro electromechanical systems and also nano electromechanical systems. These are um, those uh, those miniature electronics, micro scale electronics um, that require certain. If you have heard of lab on a chip, for example, nowadays even with there's a lot of interest in this COVID or these rapid test kits. For example, let's say I want to check the amount of glucose inside my sugar, inside my bloodstream. I can just pinprick my thumb, and I can just put it on a small petri dish, and then I can know, okay, what's my sugar level. So that's actually one example of MEMS, micro electromechanical systems. To be more specific, lab on a chip. So nowadays, even in UIA, if you have heard, even Prof. Anis, her area is also on developing MEMS and NEMS. So that her work, her work was specifically on how can we detect dengue. Like the standard way of detecting dengue is okay. You do a platelet count, and then from that platelet count, you know, okay, if it's a very low level of platelet count, okay, you suspect, okay, this guy has dengue. So what how MEMS and NEMS can help out with this kind of diagnosis is you can make miniaturized test kits. So you don't need to go to the lab and then wait for results, wait half a day. Immediately with some small miniature scale electronics, you can know, okay, this is suspected dengue, for example. So Dr. Effendi, his area is on sound and vibration. Dr. Effendi, Dr. Azni, and Dr. Diana, the three of them, their area is specifically on vibration, energy harvesting. Dr. Effendi is also working on how we can harvest energy from sound. So, like, for example, we from the sound of traffic, how can we let's say there's a busy highway and then there's always that sound. How can is there any methods or any combination of sensors, microphones that we can use so that we capture that sound, then from that sound we can convert that sound into some kind of energy, so that we can eventually use it to charge our phone, for example. But I don't think um, it's still quite a research topic. I'm not sure whether let's say along Kesas, we have our experimental setup. We try to capture, we try to record the sound, and then we try to generate energy from that. I think it might be challenging. Maybe you might need like 3 or 4 days worth of sound to generate, for example, 1 volt voltage, for example. So it's an ongoing research. Okay, Dr. Azhar did some research on um, evacuation simulation. This is a simulation of how, for example, Hajj pilgrims. If you still remember, in 2015 there was a incident in Mecca where one of the cranes fell, and then also every year during the Hajj season we hear about these cases of stampede. So one of Dr. Azhar's research interest is that how can we simulate the process of Hajj, all those millions of Jama'ah all around the world, millions of pilgrims all around the world circulating the Kaaba. How can we simulate that pattern of tawaf around the Kaaba so that we can develop a kind of evacuation? We can develop the most effective strategy in case we need to evacuate all the Jama'ah who are uh, uh, going around the Kaaba. So that's a whole machine learning, a whole computer science uh, research problem, which is continuously being studied. Okay, and then who else do we have? Okay, Dr. Diana, for masters, her area was on energy harvesting from piezoelectric materials. So, For example, we have a few patches of this piezoelectric material. Piezoelectric material is a type of smart material where we can actually by subjecting that material to some kind of strain, a certain amount of energy is obtained. So if, for example, let's say I have a piezoelectric patch, and then I mount that piezoelectric patch onto some kind of beam, and then the beam vibrates. So when that piezoelectric patch is continuously being strained, subjected to strain, tension, and compression, then a certain amount of voltage can be generated. And for PhD, if I'm not mistaken, Dr. Diana did research on MR fluid, magnetorheological damper fluid, and how it's being used in prosthetics, knee prosthetics in particular. So Dr. Zhao has left to Australia for his new life in Australia. Dr. Wahyu's area is a lot on machine learning. A lot of Dr. Wahyu is also working with Qt on ADAS. If you have heard about ADAS, Autonomous Driverless Assistance System. So that involves a combination of machine learning, different types of programming. So it involves how can we build the data set. So for example, before we can talk about machine learning, we need to build a data set, get lots and lots of data, and then supply the data into some kind of classifier, so that we can differentiate. Okay, what is the speed of the car? Is there a tendency that the car uh, is swaying towards the other lane? So that can be that's one example of where machine learning can be applied in a driver safety system. So Dr. Hasma, I think her area is in control system. I'm not very sure. Dr. Azni is also working on energy harvesting as well. So most of the members of this research group are somewhat working with energy, electronics, compared. But we also do have mechanical. Those we also have a few from mechanical background, because all those researchers who are working on energy harvesting, most likely they would have some background knowledge on vibration as well. So that's roughly the members of this research group. So I'll just show you a quick example of what I am doing, the kind of work I am doing. So I'm trying, as part of this research group, what I'm trying to do, I'm trying to develop a flat bungee warning system. And also in that flat warning system, I also want to incorporate some measurements of the level of contamination of the water, the level of bacteria in the water. So I want to incorporate I want to build a flat detection system, which incorporates IoT, so that whenever there is a certain amount, whenever the flow rate of the water, or the level of increase in the water level is beyond a certain threshold, okay, I want to trigger some kind of alarm via IoT. So what I am working on, I am building what we call sensor nodes. So this sensor node, if I can enlarge this diagram, it consists of a solar panel and then some kind of buoy. So on this buoy, I'm putting some sensors which can measure certain parameters related to water. For example, turbidity. Turbidity refers to how clear or how journey is that water. So if you have like high levels of turbidity, then maybe that's an indication. Okay, this water is contaminated. Okay, so what I have done so far, these are an example of the different type of energy harvesting devices available. We have energy that can be harvested from vibration, from flow of water, and also if you have heard about TEG, thermoelectric generator, it's an energy that is developed based on different temperature between 2 points. So the higher the temperature difference between 2 points, the higher the amount of energy that you can generate by using a TEG generator. And of course, standard solar panel is one of the most widely used energy harvesting sources, because the amount of energy that you can get is usually more compared to vibration based. Okay. So what have I done so far? Let's go straight to the point. Okay, so this is the main work that I did. So when we talk about IoT, usually how it works is that you have a few sensor nodes. So maybe I have one sensor node located in one part of the river. This sensor node measures, for example, turbidity. Then I have another sensor node in another part of a river, and that sensor node measures the pH, the acidity, or the level of alkaline inside that water. And then a third sensor node, maybe it measures the flow rate of the water. So all these sensor nodes, they have a sensor, they have a microcontroller, and then they also have some communication abilities. Like one example I can show you, a very simple sensor node. For example, I have an Arduino board, and I have what we call this UNA shield, or Sigfox shield. So I can use the Sigfox shield together with my Arduino, and then my shield also comes. My shield also comes with an antenna. That's my antenna. So by using this Sigfox shield, whatever data that I get from the river, for example, or the water, pH, turbidity, what else, water flow rate, all that can be transmitted to a cloud. Uh, if it's Sigfox, because Sigfox is like DG, like it's like Cellcom, they already have their towers. So if you were using other IoT hardware or IoT methods, you would need some kind of gateway. So you have these many sensor nodes. You have a gateway. The gateway transmits the data to the internet. But in the case of Sigfox, you don't need the gateway because Sigfox in Malaysia they already have their local distributor. And that look in Malaysia, Sigfox we already have a coverage throughout the whole of Semenanjung Malaysia. So you can send. You have this microcontroller. You have your sensors. You have a Sigfox shield. You have an antenna. You can straight away transmit your data to a cloud. That's roughly what the kind of work I am doing. So what I have got within UIA, this is some of the examples. So I had a sensor node to measure the water level at the river near Kaet, and I had a sensor buoy to measure the pH of the water. So all this data is being transmitted to the cloud. And then if I have, for example, 1 month of data, I can make a conclusion. What is the tendency of UIA to get a flood? What is the tendency of what is the pH levels of the water in UIA? So I can come up with some kind of conclusion. So that's all about Isru. So I hope all of you have, to some extent, you have an idea about the different types of projects that are being done by the lecturers in the Mechatronics department. So I hope all of you do a good white paper for your seminar work. Okay, so that's all from me. Okay, Assalamualaikum warahmatullahi wabarakatuh.